Welcome, everyone, to Njord's Wind-Assisted Propulsion Revisited live event. My name is Derick Snell, and I'm spearheading strategic growth here at Njord. Njord works with ship owners and charterers to assess, design, and install combined packages of energy-saving devices. I am super excited today to host this follow-up event to our wind-assisted propulsion event last October. And today, we're catching up with industry experts to explore their latest in innovation, as well as hear how they're overcoming some of the barriers to adoption that were identified during our last event. I've had the amazing privilege to interview each of the panelists on today's panel, and I'm super impressed with their steadfast commitment to continuous improvement, putting people first, whether that's building their diverse teams or listening to customers, and how they cooperate with one another to help move everyone in the space forward. Lastly, I'm super proud to have our very own Steen Jacobsen here. His unwavering passion for innovative solutions, environmental sustainability, and all things maritime engineering is truly inspiring. That being said, all the panelists are here to add value to you, the audience, so please take full advantage and ask questions. Just go ahead and type in the chat any questions that come to mind, and we'll address as many as possible a little later in today's program. Without further ado, let's invite in our 5 panelists. So first up, we have Cristina, COO and co-founder of Bound4Blue. Welcome, Cristina.
Welcome. Thank you very much for inviting me.
Thanks for being here. Next up, we have Jukka, COO of Norsepower. Hi, Jukka. Welcome.
Hello, everyone. Thank you for inviting.
And next up, we have Niclas, the managing director of Oceanbird.
Hello, everyone.
Nice to meet you, Nick. Thanks for being here. And next up, we have Simon, CTO of Bar Technologies. Welcome, Simon.
Good morning, everyone.
And last but not least, we have Steen, the technical director of Njord. Welcome, Steen. So we're going to start things off today with a poll, just to get a temperature of the room with the audience and see where everyone sits in terms of wind-assisted propulsion. Now, if you can manage to get to the poll without dropping out of the stream, please do so. So if you can open up notes or also QR code, go ahead. Otherwise, just skip the poll, leave it go, but can manage, that would be great. So what do you see as the biggest barrier to adopting wind-assisted propulsion technology? Is it A, the high initial CapEx? B, the complexity of installation? C, the uncertainty about fuel savings? D, the regulatory compliance? E, crew involvement? F, lack of proven long-term performance data? Or G, the managing of maintenance services? And lastly, of course, we have H, other. Some good interaction coming in here. So while we get everyone's view on wind-assisted propulsion, Steen, can you jump into the different trends that you're seeing and different types of wind-assisted propulsion out there? So you can give us a high overview on wind-assisted propulsion.
Yeah, good, Eric. Thank you. So in general, wind-assisted propulsion technologies for merchant vessels, they are aiming at reducing the fuel consumptions and CO2 emissions from vessels. And there is a couple of dominant technologies that we see out there. And one is, of course, the rotor sails. They operate on the magnet surface, and it's basically a rotating vertical cylinder that creates a pressure differential, generating thrust perpendicular to the wind direction. Then we also have fixed wing sails. A fixed wing sail resembles a lot an airplane wing, but of course they are then fitted vertically on board the ships, and they generate lift and thrust by manipulating the airflow over the surface. We also have suction sails. Suction sails, they use a system of fans and ducts to direct airflow over the elements, and so it's kind of a fixed swing with an assist to create more lift. And then we have a number of hybrid solutions inflatable sails, kites. So there's a lot of technologies out there, and we see pretty rapid development of these technologies, both new and existing. And the adoption is really picking up these years. So looking very much forward also to this event. Thanks, Barry.
Thanks so much, team. So with that overview in mind, let's dive a little deeper into each of the technologies being represented here today. And we'll start off with Cristina. If you could give us an overview, Cristina, of your technology.
Sure. At Bound4Blue, we offer a suction sail, which is named eSail, that you can see here at the back and in the photos. And a suction sail is a wind propulsion system that uses a thick aerodynamic profile, and it has a porous or perforated area and a fan at the top to generate the suction. And by doing this, what we are able to achieve is a very high lift coefficient, so a lot of savings with less square meters, so being a very compact solution and offering high saving. Today, it has been installed already on 4 ships, first installations dating back to 2021, and 6 installations ongoing. And we're working with companies like Derick Company, the Ship and Pacific Shipping, Marubeni Corporation, and others.
Thanks, Cristina, so much. All right, next up, can we hear a little bit from Jukka and your technology, Jukka at Norsepower?
Yes, of course. And thanks, Dean, for describing the Magnus effect already very clearly. So not much more on that, which the slide actually shows. And it's important to understand how the thrust is created, because the most common misunderstanding is that this would be a generator generating electrical power for the ship. But no, this is a sail creating thrust, helping the ship move with less fuel consumption. Just a few numbers describing the activity level on the market today. Our company, Norsepower, was established 2012, and until end of last year, we delivered 18 units on 9 ships, which are operating, have third-party verified performance measurements. And now in the next 18 months, we are delivering more than 40 units on 20 ships, and active negotiations going forward. So really, this is a clear show of how wind propulsion market has become much more active.
Great. Thank you so much for that, Jukka. And up we have Niclas from Oceanbird. Niclas, could you give a little presentation on your technologies?
Sure. The Ocean represent the hard wing sails. As Stein explained, it's very much like an airplane wing. We have a main and a flap in order to create the camber effect as much as possible to increase the lift forces, taking the ship going forward. One of the main advantages, or the reason why we selected the hard wing sail, is that you have a very high operability. We can operate with winds very close to the bow. That is then generating much more thrust. We are building 2 different prototypes. We are building one on land in order to work more on developing things and make sure to assemble it in a good way. And we're also doing the first installation on board a ship called Tirana car carrier. So that is ongoing as we speak right now. That's a little bit regarding our status. So
great. Thank you. And over to you, Simon. If you can explain a little bit about your technology.
BR Technology developed a product called Wing, which are large 3-element wing. On a similar, they're a rigid wing, they're foldable onto the deck. And with those 3 elements, we have the ability to change the camber, change the angle of attack, produce very high lift coefficient across a wide range of wind angle. And we do that in a passive way, so we don't require power input to produce lift. On average, we see savings in excess of 1.5 tons per wing per day across a set of global routes. But in good conditions, for example, on a Kamsarmax in 20 knots, we're seeing over 30% fuel saving. We have 2 installations on the water, 2 wings on a Kamsarmax, 4 wings on a Newcastle-Max. The wings are now in full-scale production, and you'll have seen there's many installations coming to the press, including the new LR2 for Union Maritime that are being built at SWS and YZJ in China. So I concur that it's exciting times ahead for the wind propulsion industry, and we're seeing a massive uptake and massive acceleration.
Great. Thanks so much, Simon. It does definitely sound exciting. I'm excited to also discuss a little bit more about some of the reflections on everyone's progress since we last met here in October. I'm really curious to hear both internally and externally, in terms of internally, the tech development for each of you, and also the externally in terms of the adoption and interest of your technology. So yeah, super curious to hear a little bit about that. And Jukka, let's start with you and looking on your reflections on it.
Yes, thanks. There's certainly a lot of development ongoing, and we are lucky to have many customers that we do that together with, because we have, of course, learned on the way that as we are specialists of the sail technology, the rotor sails, which are installed on ships, and then they influence how the ship behaves in different weather conditions and how the crews operate them. We are learning together with ship owners how to optimize the operation, how to make it more efficient, more beneficial for the customers. So the regulatory aspects, for example, can be considered already early in ship designs. Although we see that the retrofit market, of course, is very active for many years to come. Another aspect we see also with quite a lot of need for development, which we are focusing on, is crew training. So we are making sure that all of our customers have crews that understand very well what the Norsepower rotor sail is, how it operates, how it's maintained, what type of inspections are done to make sure that everything works as smoothly as possible. So there's quite a lot of interaction. And of course, in addition to customers, it's other stakeholders, our supplier network. Definitely the shipyards are learning all the time how to adjust and how to make sure that their operations can take new equipment in a smooth way.
That's great. Thanks for that, Jukka. And Simon, can we hear from you on that same question?
Sure. I guess we've got a multi-pronged development program going on at the moment. We're, of course, looking at how we continually develop our large wings and looking at how we improve them both aerodynamically, but also from a software control point of view, better understanding for the customers, giving better data, better optimization of routes, and maximizing the performance of the wings themselves. We're developing a smaller wing at the moment. Smaller vessels, obviously, our 37.5 meter wing is a very large structure. We're developing a smaller one, slightly different approach, which is going to bring even more aerodynamic advantages for, as I say, smaller vessels. And then finally, developing our integration team. And something we've really seen is that it's quite a complex undertaking for the customers to, both on a retrofit and a new build. There's a lot of moving parts in terms of regulatory requirement, dealing with various stakeholders, be that shipyards, ship designers and the like. So we've really developed our integration and naval architecture team to be able to hold the hand of the client right through that process and almost provide a turnkey solution, at least from a technical point of view. We're not obviously modifying ships ourselves, but making it as easy and smooth for the customer as possible.
Great. Thanks for that, Simon. And Niclas, how about your reflections?
Agree with the previous speaker quite a lot. I mean, we are in a little bit earlier stage in that way. We are doing the first 2 prototypes, which means also that we are learning quite a lot during those times. I mean, we do the first now fully on the integration on Tirana. There's been a lot of engineering work to understand exactly how it impacts the vessel. I think this is very, very important. Well, we want to make sure that when you have an installation, it's very much important to have a good performance and it should be done in a fast way. I think it's also like a maturity part of the whole era in this, that the more installation, shipyard will learn more, the class societies and everyone else is also then learning more how to handle all of this, so it makes it easier and easier for every installation, I'm sure of. I also think, I mean, for us, this to do a land-based prototype, but also a very important step with crew training, because I think crew training is also something that is important. Even if you have a fully automated system, it's new technology. you will really like be aware of how this impact, how it's handling, and all of that. So we have seen that as a very, very important step also. And then of course in the end it's very much about, I mean, you have aerodynamic, but then also regarding the automation, how well can you take care of the wind in the best possible way in order to generate that much thrust.
Thanks so much for that, Niclas. And over to you, Cristina. How about your reflections?
So I would say that, as my fellow panelists, that we've also seen a big demand on the wind propulsion side. And on our system, I would say specifically driven by the regulation, the compliance on regulation, with EU penalties, trying to avoid them. And I would also say that that is highly motivated because there are more and more installations performed, their results, they're being validated. And due to that, that's one of the important sides, being able to deliver those systems. So we last year we set up a huge partnership with the leading supplier of wind turbine towers in Europe, which is manufacturing the wind turbine towers for companies like Vestas, Siemens Gamesa. They had already the production capability there, and we've set up a whole line of production for ourselves to be able to cope with that demand. So we're seeing that growing. And also we see that we need to make a lot of improvements on our side to bring new iterations on the system to really bring the best to the client always. So due to that, we have been developing a lot of R&D internally. We have released more than 6 patents on new developments and advancements in the last month, and 5 more are coming up. So sort of shows our commitment to really lead in the potential profits and emission savings, so not taking the profit out of it. And basically these are already applied to our 4th generation of the sale. So I guess the demand is there, the supply is also there, and the advanced in technology is also there.
During our first event, we talked a lot about the barriers, and these being, for example, the main 3 that came up were the high CapEx, the complexity of the installations, and the energy constraints. And I'm wondering how each of you, and we'll start with you, Cristina, how have you addressed these challenges since we've last met?
If we speak about like the 3 main challenges on the high CapEx, I would say that in our case, our system always provided paybacks below 5 years. So when for sure, it's high in terms of monetary speaking, but then it's about how much savings are delivered and how much fast it pays off. So in that case, our system always offered that attractive paybacks, but that doesn't mean we remain stagnant, as I mentioned before. So we're always looking to strive to offer the best balance between the performance and the cost. So we have been working a lot, specifically by setting up all the whole production line. We've optimized the design, the manufacturing process of our suction sails. So by implementing these streamlined production techniques, we've really significantly reduced the costs and make our solution more accessible and cost effective for shipping companies. And what we do to balance that side, I mean, cost and benefit, we offer a free of charge preliminary analysis to evaluate that potential savings and also the effect on regulatory compliance. Then with respect to the complexity of installations, which would be the second challenge, I would say that we always designed our system to be installed in a very quick and easy way. So just to take an example of one of the last installations on the Ems Traveler, installing our sails with all the foundations already there, only took us 4 hours. So that was very fast, around 2 hours per sail. And for the Ville Bourdeaux, though it was a very windy day and rainy, so we had to stop a little bit, that took us just 1 day and a half. So it's very fast, so it requires minimal downtime for the installations. And then with respect to the third challenge, that would be on the energy constraints. As I was mentioning, our technology is axial around the profile, so it requires energy for the fan to work and to suction the air. But I would say that on that side, we've also been working to reduce the energy required. And yet today, it's the technology that requiring the energy is the most efficient one because it's able to adapt the RPMs of the fan constantly. So always making sure that it requires the minimum energy. So being very efficient. But even though that's the case, we are constantly working also to improve that.
Okay, fantastic. And Jukka, how about you and your reflections on the barriers and how you've approached them in the last 8 months?
Right. So definitely, the 3 top things, CapEx coming out clear number 1, I believe, is a topic always. And we are, of course, addressing that with looking at the volume benefits of production in series and working together with our supplier network to make sure that they are also able to achieve such efficiencies. And of course, all of the ship side related modifications and work related to installation, they're all part of the total project CapEx. So working together with the partners and the stakeholders to minimize CapEx is certainly the target of all. And we are achieving results, happy to say. On the installation process itself, there are many different ways shipyards execute deck equipment installation, and we need to be early on, hopefully as early as possible, discussing with them to find out what are their preferences and capabilities, what's their crane capacity and lifting heights and all that, to make sure that we don't complicate matters unnecessarily. Power requirements, certainly retrofit projects need to consider the available auxiliary power for operation. And this is a matter, of course, where we have also solutions. If there is a limitation required, we can implement that in software to avoid any negative consequences on the ship's power plant operation. But for new buildings, of course, it's clear and much easier to consider the power consumption requirements in different operating modes. So no problem there considered.
Great. Okay. Thanks, Jukka. And Niclas, what's your reflections on the barriers for you guys? How have you tackled those barriers in the last 8 months? So short period, but big gains being made here.
Yeah, no, but I think the CapEx issue is, of course, something that is always important, whatever product or development you do. And you also need to reflect that in comparison what the alternatives are, of course. So that goes into that. But with that said, I think also it's a quite natural way when the product mature. You heard Jukka here talk about the volume effect. Of course, that will also be a portion of doing that. Work together with suppliers long term. They are getting more and more ready to ramp up, which means that they can also increase their efficiency in their processes and other things. So I'm sure that will come as a natural part also, and something that everyone needs to work very hard on. Because the best way to get a fast change in the industry is, of course, to have a good business case. I mean, it should be good for the environment and it should be good for the profit as well. When it comes to installation, I think there is also a lot of learnings doing. I mean, shipyards are getting more and more into this and understanding of what the needs are, also regarding class societies and design institute. I think one learning from us is that we've seen a big benefit of being in an early stage, discussing different things and set up. That means that you can do it very, very fast when you come to the shipyard. So preparation and doing those things in an early stage. So I think when it comes to ship owners in general, I would really emphasize to include the manufacturing, whatever who they want to work with, but do that in an early stage, because that will help quite a lot, especially both for retrofit and new buildings. Then when it comes to energy consumption, I mean, I think this is one of the advantage with the fixed wing sails in general. It's a passive system. You have very low energy consumption in general during operation, which means that has not been the main factor for that part from our side, as I see it.
Great. Thanks so much, Niclas. And Simon, over to you. So these barriers, how have you guys addressed them over the last short period here?
I agree with a lot of what's been said already, if I'm honest. I think we do have to look at the CapEx in the big picture, and it is about the payback period and the business cases where obviously we believe our technology is very, very competitive. You know, all of us, any of us could design something which is much cheaper to build and install, but the fuel savings would obviously be much, much lower as well. And what are we here to do? We're here to decarbonize the industry. So if we want to make significant fuel savings, yes, the business case has got to stack up, but the CapEx is going to be higher, be bigger fuel savings as well. But of course, we've got to work to minimize that. And you'll know, I think Lauren would mention last time we're on here that we've got a partnership with a company in China producing the wings in a production line, which is very, very efficient and very, very quick. We've got a second production line coming online in Spain shortly. But we've also got to look at the installation as a whole. It goes hand in hand with the second part of the question. A significant portion of the CapEx is not just the devices themselves, it's the deck reinforcement, it's the work with glass, it's the work with the shipyard. So it's really important that we've developed this kind of streamlined integration program that ensures that we're standardizing as much as possible from vessel to vessel and installation to installation. So we're not relearning, shipyards aren't relearning, class is not relearning on every installation, but obviously drive the cost up. And then when it comes to energy, of course, we, as already you mentioned, wind sails are passive and we have almost zero energy consumption. So it's never been an issue for us.
Okay, fantastic. So Simon, while I have you on here, let's get a little bit more concrete with some customer examples. Can you share some data from recent installations and real world examples on fuel savings and ROI?
I mean, probably the best example is the work we've done with Propulsion Ocean, where we've been doing a lot of data logging and been working very, very closely with them. That's a Kamsamat with 2 wings installed. And all the data has now been independently verified by DNV as well. Not at our request, the Cargill and MC Shipping's request. They went to DNV and got the results verified. And we are seeing, on general, on that vessel was traded all over the world. I think it's had about 40 different port stops now in 4 continents. It's really covered the full globe, if you like. And that was an active decision from Cargill to really understand the fuel saving. We are seeing fuel savings of circa 1.5 tons of fuel per wing per day. But of course, we see savings much, much higher than that. So there's one of the data points from DNV is 20 knots of wing. So not particularly windy, but in that case, we're saving over 30% of fuel. And obviously on wings, especially on rigid wing, the fuel saving scales with wind speed squared. So you take that up to 40 knots, you know, you've made an even bigger saving. So it's been really encouraging. I think the most encouraging thing with us is our simulated savings and the savings we're seeing on the water are very, very closely aligned, which obviously then gives us confidence to provide guarantees to our customers and give them confidence when we provide a performance prediction that that's what they're going to see in reality on the water.
Super, fantastic. And Niclas, over to you. How about you guys? Any real data that you can share from some installations recently?
No, I mean, we are doing now the first installation, so we don't have any results yet from that part. So that will come early next for those installations. What we see is these case studies in general, the discussions with customer and the understanding of routing or understanding of how the impact is depending on the ship type or the ship route. And I think it's also very nice to see now a lot of these verifications saying that the result, I mean, as Barger was mentioning, that they done a lot of studies and it shows that they are very close to that. So I think in general, what you can see from SSP, RISE, DNV, and all other is that the prediction is getting very close to the real performance later on as well. And of course, it will still be very much up. How do you optimize? How do you operate, fully automate? How do you measure wind, where it comes from, and all of these things? But it's a little bit too early. The other one here has come a little bit further in that than us.
Great. Thanks, Niclas. And over to you. How about yourselves? Any data on recent installations?
Fuel savings, the fuel economy improvements are certainly one of the primary benefits. We've also learned with our customers of, as they've called, secondary benefits. When there is a high sail power capacity on the vessel, it also helps the seakeeping conditions of the ship. So the sail reduce the rolling accelerations. For example, on a ro-ro ship, our Norwegian customer Sea Cargo notices a significant improvement in heavy weather navigation. They are able to leave port in conditions that previously, before installation of the rotor sails, they would have stayed in port to wait out the weather. But now the captain is confident to go out because he knows the ship is safer and safe in such conditions for the crew and for the cargo. And this is, as I mentioned, a secondary benefit considered. Of course, in safety terms, it's a primary benefit. But thinking about how we started out by decarbonizing shipping, this is an additional benefit, and especially visible on ships where a large proportion of thrust potential comes from sails. Another very recent example from spring of this year, installation on an MR tanker owned by the French shipowner Socatra. The captain wanted to test the effect of the two large rotor sails on the tanker's deck on the first voyage from the shipyard. Ship experienced good wind conditions, 25 knots wind speed from the beam, switched off the main engine and achieved way more than 7 knots speed. So convincing the captain and the crew that yes, there is a clear benefit and the ship's sailing is much improved with the rotor sails. So these kind of practical real world experiences and statements from customers are of course very important.
Super. Thanks so much, Jukka. Over to you, Cristina. How about for you guys, some real world examples to share?
Yeah, sure. But I want to say first that the numbers that we're obtaining are not applicable to other ships. So savings will depend on a lot of aspects. So we cannot generalize savings. So for the Ems Traveler, for instance, which is a general cargo with 2 sails of 17 meters high, we're expecting around 10% fuel savings for the route they're doing. Though there, as I was mentioning, depending on the wind, you can achieve higher or lower. So I'm going to explain an on-off test that we did. That was the beginning with the captain to show him that it was working. So we just asked him to operate as normal, so at constant RPM, and he immediately saw an increase of around 1.2, 1.3 knots, more or less, due to the thrust of the sails. And on the other side, he also saw a 6 to 7% fuel consumption reduction due to the improvement of the propeller efficiency. So that is, instead of using it to increase the speed, would have been used to keep the speed constant and not at constant RPM. The sails would have delivered on that route around 30% fuel savings. So here has to do a little bit of how the ship owner wants to use the sails and how they want to operate, will deliver more or less savings, or will deliver increase of speed or improvement of propeller efficiency, depending also if they have fixed pitch propeller, variable pitch propeller. There's an interaction on how sails are being used with the ship. So basically that's on the Ems Traveler. Then numbers are a little bit different, quite higher in terms of fuel savings for the Vive le Bourdeaux. It has 3 sails of 22 meters high. Routes are very favorable, so the savings are very, very high. So these numbers right now are being sent to a third party, in this case for the Ems Traveler, to Lloyd's Register, and will be soon made public for the industry. And that would be all on the last installations.
Fantastic. Thanks, Cristina. Thanks, everyone, for sharing those numbers. And we're going to switch things over here to Steen. I see some really good engagement here with some good questions here. So I want to run through some of the questions. So Steen, could you maybe take on this portion of the webinar here and look at some of the questions with the panelists?
Yeah, Derick, I'll go. So a very interesting interaction in the chat. A lot of questions, but also a lot of answers actually already in the chat. That makes it a little bit easier. So check out the chat. There's some good links and references to various information. I have a couple of questions, so I will pitch the first one here. With the various types of wind-assisted propulsion systems in the market, could you share some insights that would help ship owners to decide on what type of wind-assisted propulsion system is a good fit for their particular vessel? Hey, Jukka?
For us, routine work to make simulation case studies for estimating the fuel saving potential either on a fixed route that the ship owner provides or variable routes, global operations, as well as then further on conducting feasibility studies which go deeper into a retrofit project, for example, evaluating structural modification needs, cabling, all the details just to understand fully what would be a total project cost, and then of course the corresponding benefits throughout the life of the ship. So these kind of studies we do routinely, and that helps customers evaluate what's the rotor sail potential, and of course we would assume other technologies can be evaluated in the same way.
Thank you, Jukka. Any other panelists want to add something?
I can go. I agree that in general, I would see it's very much maybe not the ship type, but it's also how you operate the ship, different routes and different technology, because every systems, they have the pros and cons regarding the space on deck or power consumption or different things. So I think you need to consider a little bit how you operate your ship, where you operate it, also depending on different routing, because some systems are maybe more efficient when wind come from tide or from behind, or some can operate more from the front. So I think it's important that Jukka here is mentioning that for everyone, I mean, there should be done studies to see what are the best possible for that part. But I think also another thing that is super important, we talk a lot now about the wind technology and the product. For me, it's also very important to have the full coverage of service, be able to get spare parts around the world. So the product is one thing, but it's the whole complete offering in the end. And I think that will be up to every supplier in the end here to show how are you handling this, how are you stepping up to that, because that will be very much depending on the operability of your equipment and the performance.
Cristina, any comment?
Yeah, I think it was building on top of the last speaker, that I think that the performance discussion when analyzing different wind propulsion systems is useless. So just to put it this way, all wind propulsion technologies can deliver the same savings. The key question here is what size is required for them. And then this has certain implications in our limitation in cost, CapEx and OpEx, both of them. And even at an integration level. And then it comes up on also the supplier side, what level of service they can deliver, what time they have to deliver, timings to deliver the sales, so lead time. And capabilities also of the companies. It's not just about performance discussion. And I would say that there are no systems suitable just for one single segment and other systems suitable for different segments. All systems, and I'm speaking generally, would be suitable for all ships. In our case, if I may add that, I was mentioning at the beginning, we have a list of things. One of them is that we are able to install our ships on ATEX, being non-ATEX technology, I would say. So that reduces also cost. So there are certain things, technology and how it's designed, that really make owners decide on one side or another. I would suggest, because I guess it's difficult if you contact us, all of us, for a free of charge analysis. I guess it will be difficult for you. You will receive information in different ways. And sometimes, if it's possible for you, I would suggest like working with a third party, class societies, research centers, and so on. There's a lot of third parties out there that could also support you to benchmark all of these.
Thank you so much, all of you. So I completely agree with everything that has been said. I will add one complexity from the client side that can come into play, and that is what you're trying to achieve with your wind-assisted propulsion technology. Is it regulatory compliance, or is it maximizing your CO2 reductions? So a ton of different elements you can put into place, and I'll agree team up with a third party who can help you with the overall assessment of what it is you want to achieve and then how to achieve it. And I can mention that, of course, we can also assist on that from Njord side. Okay, thank you very much. Really good question and response. I have another question here. Where can we find the most up-to-date regulations related to wind-assisted propulsion system? So we have some links in the chat, but maybe from our panelists, we have some good go-to places if you want to stay updated.
Certainly from a class point of view, the rules are starting to settle down. There was definitely a period of development where they went through quite a lot of changes, but they're becoming more and more mature. Obviously, all the class societies now have, or will have very shortly, kind of a set of requirements for the WAP technologies, and then class notation for the best installations as well. So I think leaning toward the classes is probably the place to go to find those up-to-date regulatory requirements. But of course, us and all the other WAP providers will help steer you through that process.
I think Cristina also had something she wanted to share.
Yeah, I think there's a great initiative by the IMO, All Industry Alliance, on low carbon shipping. And they set up a whole working group for wind propulsion, and they're going to be delivering a lot of information very soon. So there will be updated information also coming from the IMO. And this is also ignited by the International Windship Association, which is also a great source for shipping companies to go to.
Thank you. Let's see what else can find good questions. So I have one for you, Jukka, particularly. maybe you touched base on it a little bit, but could you please introduce your latest project? I heard that your new project has achieved a 25% emissions reduction.
Yeah, this 25% reduction in fuel and emissions is verified on the SC Connector ro-ro ship operating in the North Sea by Sea Cargo. It's not the most recent, but anyhow, this is information that we have of these operations over already a few years. I'd say the latest project that we've started now is really a great example of maximizing wind propulsion capacity with a Louis Dreyfus armature, LDA, ordering rotor sails from Norsepower, 6 units for each of the 3 ro-ro ships they are now building in China at Wushan shipyard for delivering Airbus airplane modules from France to US. So this kind of an installation will definitely be one of the highlights of wind propulsion and how to utilize such high capacity of sail power on ships in good wind conditions, which the North Atlantic is. I mentioned already one of the most recent ones, which was the operation with 2 rotor sails without main engine and more than 7 knots speed achieved. So these kind of examples show what kind of potential there is.
Thank you, Jukka. So, next question, and I will pass it on to each and every one of you. What are the biggest challenges you are finding with regards to control system integration and automation? So let's start with Cristina on the top here.
So I think I outlined a little bit before. I think that one of the biggest challenges is not on the automation of the sail itself. So that is a press on button. You press the button and it starts working. You press it off and it stops. And if it press off and there's something happening and it shouldn't be working, it stops working. So I think that the biggest challenge, I would say, is integrating our solution with other energy systems on board, with main engine, main machinery room, with different technologies. I mean, not all ships will be the same. So that is a one-on-one case. So our system can work as a standalone system, or it can connect to others. So depending on the ship owner, that will occur. And then there's other systems on top. There were other speakers talking about weather routing, and that requires collaboration, which is something we have been very much focused during the last year, I would say, on integrating our technology together with other energy systems on board. So at the end of the day, decarbonization of shipping will not happen alone by wind propulsion. It will require an integration with other solutions. So that would be the biggest challenge.
Thank you, Cristina. Niclas, do you have anything to add?
Yeah, I fully agree with Cristina also. I mean, the biggest part is, of course, how you integrate it with other kind of systems, because it's one thing if you put in, you get a lot of port. As mentioned before, you can then select if you want to have more speed or less fuel consumption, and how do you optimize these kind of things to make sure that you're getting to the most optimum way. I would say also in general, I mean, one of the challenges is, of course, for wind is difficult to measure and see exactly where it comes from, especially if you have higher systems. So that we have put a lot of effort into really understanding on different boundary layer and how to optimize these kind of things, because that will also have an effect in general. But the majority part is more the integration of other routing, how to handle the engine, and so on.
Do you have anything to add, Simon?
Well, I wouldn't only a lot of agreement. The challenge is that fitting wind propulsion technology to a vessel affects not just the thrust, but it affects rudder angle, it affects leeway, it affects engine loading, propeller pitches, all these things we've discussed. We spend a lot of time simulating vessels holistically as a whole, so that when we are providing routing information, we're not just looking at routing using the most efficient wind propulsion device, but we are routing, looking at the vessel as a whole and how we can maximize the efficiency of the whole ship ecosystem, rather than just being focused on the effect of the wind propulsion device. I think that's going to be key there for maximizing the savings going forward.
Brilliant. Thank you. Jukka, any comments to what has been mentioned?
Yeah, I agree definitely with Simon there that it's the multiple systems that can be integrated, and the challenge comes from various suppliers having some differences in their systems. But of course, this I consider more as work to be done rather than any problem as such. The main challenge definitely is to optimize then the result of this automation integration to improve the ship performance, considering those aspects of how the ship behaves, when working together with sails in different conditions.
Thank you, Jukka. How effective these solutions are in rough sea or bad weather, as high winds may exceed the design parameters and effectiveness of the system. Simon, will you talk to this one?
Yeah, no problem. There's two parts to this, and we've touched on this in the conference already. In terms of rough sea and rough weather, wax devices actually have a really positive effect on vessel motion. So they're damp rolling, they make the vessel much more comfortable and obviously more safe than without a wind propulsion device. And then, yes, all devices have a limit at which they exceed their design criteria for wind conditions. But certainly in the case of our device, and I'm sure others are similar, they have a fail-safe mode where they go into a passive or active feathered mode or non-operational mode, if you like, where they're not producing lift and they're minimizing the amount of drag. And part of the process is to ensure that we don't endanger the vessel, of course. And then, some devices can be folded onto the deck as well if the owners.
What are the maintenance requirements and lifespan of these wind-assisted propulsion systems? The owners and managers always concerned to get the system going effectively, efficiently, without much efforts. Jukka, will you speak to this one?
The maintenance programs, inspection protocols to support the monitoring of rotor sail condition and performance. We also do that by ourselves with remote diagnostics and monitoring systems when we have a service agreement with the customer. So we have daily updates and monitoring of systems to make sure that everything is running appropriately. And if there is anything to check, we can be in contact with the ship. And of course, the minimizing of work and the maximizing of availability is the target. So we've developed our systems to be as low maintenance as possible. But of course, everything needs attention at some point. So we've also tried to make such operations such that they improve and take action and less requirements for external people to come on board.
Thank you very much, Jukka. Yes, Cristina?
In our case, if we speak about suction sails and how we have developed our e-sail, really it's a very simple technology because everything is electric. So there is no high rotational speed. So the only rotating part would be the fan at the top, which is like an industrial ventilator, which just must be changed every 15 years, so once in a lifetime. And there is also no complex parts, so it operates like a wing sail, so really low. And that simplifies a lot the operation load. So basically, it's very simple from this mechanical point of view, and around 90% of the maintenance tasks can be done directly by the crew on board, and really are very common to current technologies that are already available on ships. So they don't require additional training to make that maintenance, I would say. So that reduces a lot those costs. And we also do remote monitoring, that is very helpful. And we deliver those manuals of inspection, so they can deliver those maintenance activities by themselves, or we can also handle them ourselves. So we can offer that to them.
Cristina, I think this is interesting also to hear from Simon and Niclas. So Simon?
Yeah, I mean, obviously, wind sails have no rapidly moving parts, no wear parts. The maintenance is very, very low. We equate it to something like a deck crane, but without the draw gear. It's all stuff that's very well known to the crew, so it kind of greasy operations and hydraulic system maintenance. Definitely the feedback we've had from the crews on board that they are encouraged that although it looks different, mechanically it's something they really understand and really are very, very comfortable with. So that means the majority of the maintenance can be done on board, and we don't require any major component replacement through life at all. And of course, we're doing remote monitoring. We've also got full strain gauges installed in the wings, so we're doing full load monitoring. Over time, we'll develop a predictive maintenance program as well, based on the conditions the ship actually experiences or the wings are actually experiencing.
Definitely, thank you. Niclas?
Yeah, no, I mean, it very much to echo what Bar is saying, because for us, we have the same technology in that way. So it's, of course, a hydraulic. I think that goes with everyone. You design the wing for the lifetime of the ship. I mean, so that is for first. And then regarding the service part, I mean, since it's a passive system, I think also we do some checks and make sure that how things are behaving and so on, more for control it that way, but not any regular service. So it's normal service like greasing and taking care of the hydraulic.
Okay, let's try this one. Kongsberg has recently disclosed a new concept of eco-friendly boat carrier with combined wind-assisted propulsion system. What do you think about this solution, about combining different wind-assisted propulsion systems? Is that efficient? We previously talked a little bit about attack angles and pro and cons on the different types. So combining the different systems, what is your perspective on that? I think we will start with Niclas. You were just there.
Yes, for a wing sail, you can also then, of course, have an advantage of having multiple wing sails, because then you can utilize them as a larger wing sail and so on. I'm not the expert in all the other technologies. Very difficult for me to say how that would benefit from it. But I mean, there is, of course, a lot of other things that you can consider. I mean, if you make the ship more stable, so maybe the other kind of technologies, that could be for decarbonization and so on, or in combination with batteries, other things like that. So there is, of course, a lot of learning going on in the industry. I'm sure that with combining different technologies, and eventually, I mean, I think also in general we will see more and more learning from each other, also in the RAPS community, in that take advantage from each other.
Thank you. Cristina, do you have something to share on this?
I cannot say anything about how those systems will be used effectively. For sure, I can build on top of the other speaker, which is on the combination of technologies. Really, as I was saying before, that is challenging. That for sure, it more activities to be done to make it work in an optimum way altogether. So I guess combining wind propulsion technologies at the beginning might seem sort of difficult, I would say, because they have different sweet spots. So I'm very curious to know more on this eco-friendly boat carrier and how they want to combine the two technologies at the same time, and what they thought for. I'm very looking forward to knowing how they want to integrate them together with other solutions, which I guess will be on board that ship.
Any comments?
Yeah, I think it's a very interesting concept Kongsberg has developed. And we've had extensive discussions with them about various different configurations on different kinds of ships, including bulkers. Of course, interaction effects between same kind of sail devices and different kind of sail devices are one aspect to really pay attention to. Of course, in addition, the ship's structure influencing the sail. So different configurations definitely worthwhile looking at. But as Cristina said, one of the complications still today can be that there are multiple control systems that exist. So unless there's a combined or a common system to be used for controlling, then it will be perhaps rather more complex than just with one.
Thank you.
Just another comment there regarding that, and I think I fully agree. But I think also regarding the performance part of this, it's very difficult then to see what is coming from different technologies. So to follow up on performance would be much more difficult to highlight that.
Interesting. Simon?
Yeah, I think it's interesting. I'd love to know exactly what taken from this conclusion. I mean, I assume they're trying to look for different sweet spots or different devices to provide different efficiency at different apparent wind angles. And I mean, from our point of view, from a rigid wing point of view, that's kind of what you do by changing the camber. We have a sail which is efficient upwind because it's very flat and cambered. And then we have a much more cambered wing when we're at wider wing angles. We want a higher lift and drag coefficient. So I'd be really interesting to know their thought process and exactly why they've taken that route. But it's certainly going to add complications both in terms of control and performance verification levels.
It's going to be interesting to follow and give some thoughts. Thank you. I believe we don't have time for any more questions, but thank you so much for all the questions out there. And there will be a possibility for the panelists to respond to the questions in the chat if they want. So over to you, Derick.
Thanks, Dean, so much for running the question period. And thanks so much, panelists, for the great responses. And mostly thanks to the audience for bringing up a lot of engaging questions here. So let's have a little reflection on the poll results here and see how the audience sit on the questions we posed here at the beginning of the panel. No surprise, the high initial CapEx was the main option that our audience selected here. And then with the close second was the uncertainty about the fuel savings. We've addressed a lot of these already. I saw another audience question that does relate to the high initial CapEx. They're mentioning something about the leasing. Or other options in terms of how they're addressing the CapEx. Some ideas there, but I'd like to hear from the panelists what their thoughts on that. Maybe we can start with you, Simon, with the poll results. Is there anything that stands out here or surprising?
Not really. When it comes talking about the unconverted fuel saving, we've got to split that into two parts. Is that uncertainty because of unpredictability of the weather, and obviously wind propulsion devices are based on the wind. And if that's the case, then we need to do a better job as an industry of providing good statistical analysis of what the fuel savings are likely to be on a route. But then I think owners have got to understand that statistical analysis, you can do the road 50 times, you'll get 50 different results depending on what the weather gods are doing that week. When it comes to uncertainty about fuel saving in reality in a given set of wind conditions, then we've got to look to third-party verification, be that through class or research organization. And, I know there's work going on to standardize the ITGC test procedures associated with that as well. And then, we've got to really provide performance guarantees, which is what we do, so that we are financially guaranteeing the clients are getting the return that we say we're going to give them.
Great. Thanks, Simon. How about you, Niclas?
I think it's quite there is always a high focus on CapEx, but together with CapEx is also come with the savings part. So, it's all in the end about return on investment. So, of course, we need to be able to show results, and we need to show that in a more, maybe better way or unified way or something like that. But there is nothing that for me sticks out. It's CapEx, and it's all about the performance. And that's the reason why you put a wing sail on or doing any of these things is to get the performance.
Great. Thanks, Niclas. And how about you, Cristina? Over to you. Any reflections on what you see here?
I think it quite just surprised me a little bit, the one from wind performance data. I think that the wind propulsion has been there for a while, and I think the number of wind propulsion installations are equaling those of new alternative fuels. I think there's much more information from the IWSA. So really, there's been data out there. It's not just about Bound4Blue putting our data, but also the suppliers that are here today and much others that form part of the IWSA. So that is really striking me a little bit. But I guess we still need to make a lot of effort to keep delivering those results to the industry. And then on the uncertainty about fuel savings, it's true at some point the wind propulsion performance relies on the wind availability, and it relies on how the ship will be used. So it's true that really projecting those future savings would depend and vary widely on a lot of aspects. But so does the fuel costs, and people are projecting fuel costs. So it's about projecting something that in fact can be easily predicted and computed, because we have a lot of information out there about wind, and it can be easily computed. And we can optimize those benefits in the long term. So that's something on top that wind propulsion can deliver. Even applying weather routing if needed, which has also proven to bring a lot of good results.
Thanks for that, Cristina. And over to you, Jukka.
Yeah, very much topics that we work with on a daily basis. The CapEx question, not surprising, and that's why we've teamed up with Mizuho Leasing from Japan and Inolines, which is a ship owner in Japan, to set up a leasing concept which we can offer customers for investing in road-to-sail technology. And it's addressing the cash flow aspect, of course. I mean, return on investment is the primary evaluator there, but to provide a leasing solution with terms such as 5-year lease term, a minimum, and then possibility to either continue the lease, buy the units after the lease term, or if the situation is such that the ship no longer operates in a beneficial way, you could even return the units either to the provider or move them on another ship. So reinstall them on a ship that then operates on a favorable route. So this brings more flexibility to those owners who are considering that whether the next charter contract will support their investment in a way which gives them confidence. So this we've realized and are providing this lease concept now.
Interesting insights. Thanks, Jukka. How about Njord, Steen? What are your thoughts here on what?
No, it's pretty much as expected, and also the dialogue we have with our clients. It's very much about the return of investments and the regulatory compliance. And so we don't see that the lack of proven performance data is a big issue. I think there is quite some trust in the industry for the polar plot diagrams, the theoretical models. I think what the ship owners are mostly concerned about is actual fuel savings they will see on the given voyages that they are on. If they are not on fixed routing, it's a big question mark how risky that business case is going to be. And there I can add a comment on Fuel EU Maritime. The upcoming regulation will actually de-risk it for ship owners because they will get a fixed premium or reward when sailing on EU when they have wind-assisted propulsion on board.
Thanks so much, Steen. If you can spare 5 minutes, we would very much appreciate your feedback. It will help us improve our future events and be able to deliver more value in the future. Thank you so much to all the panelists for offering up your expertise and your time today. And thanks again to the audience for the great engagement. Stay tuned for our next event, which is coming up here after the summer in September on hull management technologies of the future. So looking forward to that one. Thanks everyone again, and we'll see you again in September.